Okay, let's unpack this. Have you ever wished you had a shortcut? A way to grasp the critical nuances of something really important, something that feels like it could save you from a major headache down the line.
Hmm.
Well, today, we're taking a deep dive into exactly that.
Yeah.
We're going to pull back the curtain on the VMCA V12 exam. Now, not to help you study for it necessarily,
Right.
but we're using as practice questions more like a lens, a way to extract some genuinely surprising, essential insights into architectural design, enterprise deployment, and maybe most critically, data security and recovery best practices.
And what's really fascinating here, I think, is that while these are technical questions, definitely technical, they highlight these universal principles for robust data management.
Okay.
Our mission today really is to turn these specific scenarios into those aha moments about why certain decisions matter so much in the real world.
Got it. So grab your mental notepad because we're about to distill some serious knowledge from our stack of sources for you.
Let's do it.
All right, let's jump right in. First topic, understanding backup copy jobs and data tiers. So imagine a customer's backup policy requires offsite copies and specific daily restore points. To correctly plan the backup copy job settings, what's the very first thing you need to understand?
Well, the first thing is a backup copy job. Fundamentally, it duplicates an existing backup.
Okay.
So to configure it properly, you simply must first understand the settings and the schedule of the primary backup job, the
Yeah.
one it's actually copying.
The source, yeah.
Exactly. And this is especially crucial for what you might call gold tier backups. The most critical data, the stuff with the most stringent requirements, more frequent backups, longer retention.
Right, the high priority stuff.
Yeah. Without knowing those foundational details of the primary job, your backup copy job just isn't going to meet those customer goals for offsite copies and restore points. It can't.
So your copy is only as good as the original it's duplicating, especially for your most critical data. It's all about knowing your foundational requirements first.
Precisely. You can't build a good copy on an unknown base.
Okay, that makes sense. Now here's where it gets, I think, really interesting. Sensitive systems. Imagine a group of SQL Server always-on cluster systems, highly sensitive to virtual machine stun. What's the recommended backup configuration here?
Yes. VM stun. That's basically a disruption, a brief pause that happens during a VM snapshot.
Which you don't want on sensitive SQL clusters.
Absolutely not. Especially with always-on clusters, you need to avoid that. So the best practice here is actually to use Veeam agents for Microsoft Windows directly on the cluster nodes themselves.
Inside the OS, not at the hypervisor level.
Exactly. These agents can be configured specifically for failover clustering, and they back up the SQL databases without using VM snapshots. That's the key. No snapshot, no stun, no disruption to the cluster.
That highlights a really crucial point then. Sometimes the best approach for critical performance-sensitive applications isn't the standard VM backup method. You need to think differently.
You do. It prioritizes the application's uptime above the sort of convenience of a simple VM-level backup.
Right. Adapt the method to the need. Okay. Let's shift gears slightly. NAS backup sizing. When you're planning a NAS solution, what crucial metrics often get missed during discovery? Things essential for later design and sizing, and like you hinted earlier, it's not just the total data size, is it?
No, definitely not. Total size is just the start. There are, well, three really vital pieces often missing.
Okay, what are they?
First, the actual retention requirements.
Okay.
This dictates the total storage you'll need over time, not just today. Big difference.
Right, how long you keep it for.
Second, and this trips people up a lot, the total number of files, often in the millions.
Millions. Why does the number of files matter so much?
Because processing millions and millions of small files can absolutely tank backup performance. It's a common, often overlooked bottleneck. It takes way longer than backing up the same amount of data in large files.
Huh. Okay, that's a great insight. And the third?
The third is the amount of source data before any deduplication and compression. That's your fundamental raw number. You need that to figure out the initial storage capacity required before you even think about savings from dedupe.
So don't just look at the terabytes. Understand the nature of the data. Especially watch out for those millions of small files.
Exactly. Small files can genuinely be a big problem.
Okay, so we've planned the backup, we've sized it, considering the file count. Now, security. Designing for immutability, ransomware protection. If a customer demands strong security and data immutability for their primary backup repository, What option really fits the bill based on best practices?
Right, this is critical today. The best practice, the sort of gold standard, is a Linux repository using XFS file system integration combined with single-use credentials and, crucially, immutability.
Okay, break that down a bit.
Yeah.
Linux, XFS, single-use credentials, immutability.
Sure. So the hardened Linux repo provides a secure base. XFS integration enables really efficient block cloning, saving space. Immutability means the backup data literally cannot be deleted or modified, even by an admin, for a set period.
Okay, that's the protection against deletion.
And the single-use credentials are key against ransomware. They prevent malware that steals credentials from logging back in later to delete or encrypt the backups.
So it's a multi-layered defense.
It is. It's a core best practice. This isn't just theory. It's a direct shield against ransomware. Your backups are your last line of defense. They have to be unassailable.
Absolutely paramount.
Mhm.
Now let's talk about fixing things, or maybe making things worse. Imagine you upgrade your current repositories. They now have significantly higher throughput. You're expecting faster backups, right?
You are?
What new issue might surprisingly pop up?
Ah, the classic shifting bottleneck. This happens all the time.
Okay.
So your local backups might indeed speed up. Great. But the next step, maybe the backup copy jobs sending data across sites, those could suddenly become limited by insufficient network bandwidth between the sites. Your shiny new repositories are trying to push data much faster than the network pipe can actually handle.
So you fixed the repository speed, but now the network is the problem.
Exactly. You've just moved the bottleneck further down the chain. It was always there, perhaps, but hidden by the slower repositories. Now it's exposed.
That's a critical lesson in systems design, isn't it? Fixing one problem can just reveal another. You need to look at the whole picture.
Absolutely. Comprehensive planning means looking beyond the immediate fix, considering the entire data path. Storage, network, compute, they're all connected.
Okay, thinking about that whole picture, here's another common issue. Conflicting requirements. So say there's a technical requirement. Gold tier backups must run every hour, high frequency.
Okay, low RPO.
But that directly conflicts with another requirement. All backups must complete within the hours of 5 p.m. to 8 a.m. local time, a restricted window. Which one wins? And why is this such a headache?
Yeah, this is a direct clash. It's a recovery point objective, the RPO, how much data loss is tolerable, driving that hourly frequency versus the operational backup window.
You can't do both.
Well, think about it. If an hourly backup job takes, say, 30 minutes to run, you simply can't run it 24 times within a restricted 15-hour window, 5 p.m. to 8 a.m. The math doesn't work.
Right, you need 12 hours just for the backups, assuming zero gap.
Exactly. And jobs often take longer, or you need gaps. So this isn't really a technical problem you can just configure away. It's a fundamental conflict that requires a business decision.
So you have to go back and ask.
You have to go back and ask, which is more important? The very low RPO, meaning frequent backups, or sticking to that restricted operational window, one usually has to give.
That's a classic real-world trade-off.
Yeah.
Speed of recovery versus operational rules forces a tough prioritization.
It does, and it's better to resolve it during planning, not after things start failing.
Good point. Okay, let's talk management in larger setups. For big environments needing granular access control, delegated administration, specifically for restores, what components should be deployed?
For large environments, the go-to component is typically Veeam Enterprise Manager.
Enterprise Manager, why that specifically?
Because it provides a web-based interface designed exactly for this, defining and managing role-based access control RBAC policies.
RBAC.
Right. It lets you delegate very specific permissions. For instance, you could allow the database team to only perform SQL database restores, or the VMware admins to only restore VMs in their cluster without giving them full admin rights over the entire backup system.
So it's about secure delegation.
Exactly. It's key for both security and operational efficiency in large teams. You give people the access they need, but no more.
Makes sense. Keeps
Okay.
things manageable and secure. All right, let's loop back to that crucial discovery phase again, but focus on the virtual infrastructure itself. What key info is often missed there, but is absolutely essential for good sizing and planning?
Two pieces often get overlooked, surprisingly. First, the number of vSphere clusters.
Why the clusters specifically?
It gives you an immediate sense of the scale and complexity. Managing backups across 10 clusters is very different from managing across 2. It affects proxy placement, network considerations, everything.
Okay, and the second piece?
The total number of virtual machines. This seems basic, maybe too basic, but it's fundamental.
Right, just the raw count.
Yes. It drives everything repository capacity estimates, the number and size of backup proxies needed to process the VMs within the window, licensing. Missing this, or getting it significantly wrong, leads straight to undersized infrastructure and future headaches.
Don't skip the basics then. Incomplete discovery leads to problems down the line. Simple as that.
Pretty much. Measure twice, cut once applies here too.
Okay, one more planning scenario. Migrations. You're planning to buy new physical servers, new repository storage for a big migration project. You've got the specs for the new gear. What else? What crucial piece of information is needed to properly define the implementation and the whole migration process?
The single most critical piece of information, often missed in the excitement of new hardware, is how much backup data is currently stored on the old hardware.
The existing data volume. Why is that so critical?
Because that volume directly determines how long the migration itself will take. It dictates the network bandwidth needed between the old and new systems. It tells you if you need temporary swing sturdied on the new hardware just to handle the data transfer influx.
So it's not just about setting up the new stuff, it's about the moving part.
Exactly. Migrating terabytes or petabytes of backup data is a huge task. You can't plan the logistics, the time, the potential downtime or performance impact during the migration without knowing that starting volume. You're flying blind otherwise.
Plan for the data volume first. That seems obvious when you say it, but I can see how it might get overlooked.
It happens more than you'd think.
Okay, final point. Bringing it back to ransomware protection, which we touched on with Linux repos. If a current storage configuration isn't hardened enough, maybe it's using older methods, what specific steps should be taken to correct it, following best practices?
Right. If you're using, say, CIFS extents in your scale-out backup repository, that's generally not considered ideal for ransomware resilience anymore.
Why not CIFS?
Because those shares can often be easily accessed and manipulated if the Windows credentials used to access them get compromised. Ransomware loves shared folders with weak or stolen credentials.
Okay, so CIFS is out for hardened repos. What's the fix?
The recommended best practice is twofold. First, add hardened Linux repositories to each scale-out backup repository, SOBR.
Add the secure option.
Yes. And second, you need to evacuate the backup data from the existing CIFS extents onto the new hardened repositories.
So migrate the data internally within the SOBR.
Exactly. This gets your backup data onto the immutable, more secure storage tier. It's a concrete, actionable step to seriously strengthen your defense against ransomware, encrypting, or deleting your backups. Don't leave them vulnerable on easily accessible shares.
That's a really practical takeaway. Add the hardened repo, then move the data. Protect that last line of defense.
Absolutely.
This deep dive really hammered home for me that being truly well-informed isn't just knowing the specs. It's about seeing the connections between systems, anticipating those potential pitfalls, understanding the trade-offs, seeing the whole forest, not just the individual trees.
Well said. It's systems thinking applied to data protection.
So thinking about that bigger picture,
Right.
what does this all mean for you listening right now? Given everything we've discussed today, the planning, the potential conflicts, those unforeseen bottlenecks, the security implications, what aspect of your own organization's data protection strategy are you going to take a deeper dive into next?